Hello everyone, welcome to this lecture number 4 of this Unit 5 Flexible Manufacturing System. This is Mr. Soyog Patil, working as Assistant Professor in Department of Mechanical Engineering, Sharad Institute of Technology, College of Engineering at Draw Ichalkarni. Today we are going to see the robotics and sensors used in the robots. Okay, so we will see. First of all, we will see what is meant by sensor. Okay, a sensor is a device that measures physical input from an environment and converts it into the data that can be interpreted by either a human or a machine. Okay, so that means these sensors are basically used to measure, or it is used to measure the input data, and it is converted into those signals, and that signals may be interpreted by either human or the machines. Or again, we can say this: most of the sensors are electronic sensors. Okay, the data is converted into the electronic data in most of the sensors, but sometimes some simple sensors are also available, such as the glass thermometer we can see here. So these are the some of the electronic sensors which senses the input data from the environment, and which converts into the electronic signals. But here in this simple case of this thermometer, so it is a which presents a visual data. Okay, this sensor senses this environmental conditions, that means the temperature, and it gives this physical value of this, or it gives the physical signal. Okay, so these are the simple sensors. Then examples of these sensors are: sensor changes a robot from a dumb into this intelligent. Okay, so these sensors converts a simple robot or a dumb object into an intelligent object or intelligent human or robot. Okay, then what are the needs of these sensors? So these sensors are required for this localization. Okay, so these sensors are needed for localization, then to detect the obstacles in this path, then to internal information, to collect the internal information from the system, from the machine. Okay, again these sensors are needed. Basically these sensors senses this input data. Okay, then it plan on that input data, and it acts accordingly. Okay, and it acts accordingly in order to get this output signals. Okay, what is this is mean the sensor. Okay, next point, it is types of the sensors. Okay. Basically there are two types of these sensors. One it is exteroceptors, and second one it is proprioceptors. Okay, that means again we can say external sensors and internal sensor. Okay, so we will discuss these types of the sensors in detail. So here first type of the sensor is contact sensors. Okay, so contact sensor senses, okay, these sensors that determines the size, shape and weight of etc. Okay, by touching. So that means these contact sensors are the sensors which senses the input data by touching or physical contact. Okay, with the help of this physical contacts. Okay, and here we can say these are the touch sensors, and this is the application of these touch sensors, where this when this force is applied here. Okay, this will become in contact with these two. When these two nodes come in contact, so this current will flow here from this circuit, and this current will be measured in terms of this voltage measurement. Okay, in terms of this voltage it is measured. So therefore this force applied is measured in terms of this voltage. So whenever there is a contact between these two nodes or these 2 points, then and then only this will be measured. Okay, so therefore this touch or this contact is required here. Okay, so these are the contact sensors or touch sensors. Second type is force or stress sensors. Okay, so here to measure this robotics system forces, physioelectric sensors are used. Okay, so therefore this, in order to measure this force or stress, here we can see here this is in this figure. So this whenever we are applying a some certain force on this component, okay, it will measure in terms of this voltage. Okay, that force will be converted into the voltage. Okay, so by using these piezoelectric sensors we can measure these forces or stresses in the components. Then second type, it is non-contact sensors. Okay. In case of these non-contact sensors, there is no not necessity of this physical contact. Okay, so this approximate so therefore the example of these non-contact sensors are proximity sensors. Okay, these proximity sensors sense and indicate the presence and sometimes position of the physical contact or physical object. Okay, it's basically these proximity sensors are used to identify or to detect the physical presence and absence of the obstacles or components. Okay, so types of these proximity sensors are again optical proximity sensors. A complete optical proximity sensor includes a light source, okay, and a sensor that detects light. So this sensor which detects lights is called nothing but it is called as the optical proximity sensor. Okay, these sensors detects objects directly in front of them. Okay, by detecting the sensor's own transmitted light reflected back from the object surface. Okay, so here in this case we can see this sensors transmitted some light and it will be detected by again back reflection of this light. Okay, and so that whenever there is an object in front of this sensor, it will detect that or it will reflect this light from that object, and this it will detect the physical presence of the component. Okay, in similarly in this photoelectric proximity sensor also, so these sensors also detects on the based on the same principle. So therefore this physically presence and absence of this object is detected by this light source. Then third type is acoustic proximity sensor. Okay, in this acoustic proximity sensor, this acoustic or the sound of this object or sound of the component is measured with the help of this proximity sensor. Then in case of this capacitive proximity sensors, basically this capacitive proximity sensor works on the principle of a change in the capacitance with the environment. Okay, this capacitive proximity sensor is a non-contact type device, okay, and that can detect the presence and absence of this physical object. Then again, these proximity sensors utilize the electrical proximity of the capacitance and the change of this capacitance based on the change in the electrical field around this active phase of the sensor. Okay, in front means here in this capacity proximity sensor, this electrical field will be this electrical field will be interrupted. Okay, whenever there is an object and the capacitance of this will be changed here. Okay, so this change in the capacitance is measured, and the physical presence of this object or absence of this object is measured with the help of this capacitive proximity sensors. Okay, this type of the sensors are mostly used in the robots. The next type of the sensor is range sensors. Okay, this range sensor provides a precise measurement. A range sensor provides a precise measurement of the distance from a sensor to an object. Okay, so that means it gives a correct or precise measurement and the distance between the sensors and the object. So there are again two types of the sensors, or active and passive sensors. Okay, in case of these active sensors, these sensors sends signals into the environment and measures interaction of the signal with the environment. Okay, so in case of these active range sensors, these sensors sends signals into the environment. Okay, and again it measures interaction of the signals with this environment, for example radar or sonar sensors. But in case of these passive sensors, these sensors records signals already present in the environment. Okay, already, for example these video cameras. Okay, in case of these video cameras, this video camera records this physical signals present in the environment only. Okay, so these are the passive sensors. Next one, it is ultrasonic ranging system. Okay, this is the example of this active sensor. So in case of this ultrasonic ranging system, this sensor sends this original waves of this component or sound, and whenever there is an object and or the object comes in front of this sensor, okay, so these waves will be reflected back. Okay, and here we can say the green lines are the reflected waves. Okay, and when these reflected waves comes to this sensor, again it receives this signal from this reflected waves, and it measures this distance. Okay, so therefore this distance r is measured with the help of this ultrasonic ranging systems. Okay, ultrasonic sensors. Then velocity sensors. Okay, velocity sensor is the sensor that responds to velocity rather than this absolute position. Okay, this velocity sensors responds to the velocity rather than the absolute position, as we seen in the previous examples. And this example of this velocity sensor is dynamic microphones or this tachometers. Okay, in case of this tachometer, this tachometers detects this velocity or the speed of the rotating object. Okay, and it can be and it is converted into the certain output signals. So here velocity of this component is detected. Then applications of these robots. Okay, so these are the various, now we seen the various types of the sensors used in the robots. Okay, and now we will see the application of these robots in the various industries. So these robots are basically used in assembly operation, inspection, then palletizing and depalletizing, then in case of this painting or in the tightening of this components, or as well as in welding applications, as well as these various robots are used. Okay. In case of this assembly operations, these electronic component assemblies and machine assemblies are the two areas of these applications. Okay, where these robots are used in electronic application assemblies and machine assemblies. Or again we can see in the automobile sectors also these robots are used in the assembly operations. Then in inspection of application, industrial robots are used for inspection applications in which the robot end effector is a special inspection probe. Okay, on this inspection robot, this end effector is a special inspection probe. Okay, which detects or which inspects this components. Then in palletizing and depalletizing, robots are commonly used to palletize and depalletize the boxes because they can be programmed to move through a array of the box positions layer after layer. Okay, here we can see this palletizing and depalletizing of this uh, pallets can be done by this robot. Okay, so this can pick and place on this required position or required condition location. Okay, so this palletizing and depalletizing, again robots are used in the drilling operation. In hole drilling, special purpose robots are also used for drilling operation at the certain locations. Okay, then in case of this paint and compound spraying, again robots are used. So robots provides a consistency in the paint quality and widely used in the automobile industry for medium batch production. Okay, so these robots are used because this it gives the consistency in the paint quality. Okay, it gives the good quality painting, so therefore this robots are used. As well as these painting booths are hazardous because this paint material is often toxic and flammable. Okay, so therefore it may be hazardous for this human or operator. So therefore because of that, as because of that also, in the painting booths these robots are used for this painting of this automobiles. Okay, so it is also one of the application of this robot in the industry. Then in spot welding is the most common welding application found in the manufacturing field. Okay, where this most of the times these robots are used for this spot welding. Then in case of this arc welding, this shipbuilding, aerospace, construction industries are among the many areas of this application of this arc welding, where these robots are used for the arc welding. Here we can see this is the robot which is used for the arc welding in the industry. Then in case of this fastening, as well as these robots are mostly used. Okay, robots are commonly used for applying the threaded fasteners in the automobile industries or in the fastening of the vehicles or fastening of the wheels. These robots are used for fastening application, fastening purpose as well as. Okay, so these are the various applications of this robots. Now summary of these applications of the robots. So it is because of this hazardous work environment for the humans. Whenever there is a hazardous work environment for the humans, robots are basically used. Then in the repetitive work cycle as well as whenever there is a repetitive work cycle, the programmed robots are used to perform the repetitive work. Okay, so the efficiency will be increased in this case. Then again, difficult handling task for the humans. Okay, the tasks which are difficult to handle for the humans, in such a tasks these robots are used. For example, in the foundry, while melting the metal and pouring it into this mold, in such applications it is a difficult task. In such applications robots can be used. Then again, in multi-shift operations, this basically robots are used for to get this more efficient work. Then infrequent changeovers, whenever there is infrequent changeovers in this scheduling or positioning of this production, so these robots are used. Then part position and orientations are established in the work cell. Okay, so these are the various points where these robots can be used. Thank you so much. Friends, thanks for watching this video. If you like this video, please share, comment and like this video. Then subscribe to my YouTube channel and click on the bell icon to get notified for more videos on this CAD/CAM subject. And thanks for watching. Thank you so much.